So I'm going to talk for a few minutes, and then I'm going to turn it over for the more interesting stuff to my son Christopher, who's built various things that he thought you might be interested to see. So I was going to start off by talking about a long time ago, I started making software stuff. Was the predecessor of Mathematica. That was 33 years ago, and after that time, we've sort of built these many layers of software. These days, the pinnacle of those efforts shows up in Wolfram Alpha and shows up in things like Siri, where you can just talk to your phone and ask it questions. And sort of the idea is to try and take the systematic knowledge that exists in the world and make it so that if a question can be answered on the basis of that systematic knowledge, it should be automatic to do so. So if we're lucky, oops, that doesn't seem very promising. Well, yes, okay, that's good. That's a really good sign. We can ask it, the number of goats in Greece or something, and with luck, it will know that piece of systematic knowledge. Or we might, it's divided by. How about divided by the U.S.? I don't know what that will look like. Okay, it's interesting. There are more goats in Greece than in America. I didn't know that. Or you could ask it something like, which sort of mixes a kind of real-time feed of data with computation. You say, where's the GOI satellite if you want to hide and make sure that you're not spotted in some future mapping thing. Okay, right now you have to be in Antarctica if you want it to be showing up on satellite, but it should tell us where the thing will, when it will next rise over us here. So you can hide then if you want to. Or you could say something like, you could start asking all kinds of questions. You could ask it to do some computation if it wakes up here. Okay, who knows? No go. Okay, so like you say, add two colors together, it'll tell you the answer. Or let's say you do something a little bit more hacky. Let's say you type in some hexadecimal number or something. If you're trying to debug something, you might as the result, and it'll tell you things about what it's like as a various kinds of integer and so on. Or let's say you're trying to debug a different kind of thing. It's something like this. You can try and figure out where on the human genome something like that shows up there. Oh, okay, I got just two places on the human genome that showed up. Somewhere deep inside an internal version of Wolfram Alpha is my complete genome, but that's not being exposed, at least not yet. So there are all kinds of things. So Wolfram Alpha knows about lots of kinds of things, and some of them I think are probably useful to in the making of things. You could type in something like this. I'm not sure how useful this is, but no, it didn't. How about that? I have no idea what 7-segment that is, but 7-segment display. I might, as a human, be able to guess what that is. There are all kinds of funny things that you can find inside Wolfram Alpha, and we're sort of steadily trying to teach it everything. Or you could, let's say, you could ask it something like this. This is sort of interesting because we're saying, let's say we want a 542 ohm resistor. That's not something that you can actually buy as such. But there'll be a combination of resistors which can be made that will make you roughly a 542 ohm resistor. This is sort of a sample of something where there's much more to come, where you kind of tell the system, I want something which does such and such a thing, now automatically go and figure out how to achieve that with particular components. Actually, we have a much fancier version of that that's on its way now. We have a product that we brought out called SystemModeler, which is a system for doing large-scale system engineering. So it's actually been its predecessor versions have been used to design things like gas turbines and things with 50,000 components and so on. And it's something which essentially can manage dealing with all the equations for a system like that, then put them into essentially Mathematica, solve them, and figure out what the system will do. And what you will see coming soon is the ability to take some specification of a system like that and be able to query it from Wolfram Alpha. So you'll be able to say, perhaps from a voice device or something, I've got this giant gas turbine in front of me. If I move this lever in this way, what will happen? And then the back-end system will do the modeling, figure out what will happen, and then tell you whether or not it's a good idea to move that lever or whatever. Let's see, a few other things just to show you a little bit of Wolfram Alpha, one thing you might say is, you might say, let's look at our little 3D logo here, and you can probably go here maybe with luck and tell it to make that interactive, and you can move it around and so on. But you can also, let's what we wanted to do there. You could also go and ask it, say, I want to make a version of this logo. So you can go here and just pull it up, and it says what 3D geometry format you want it in. So for example, I might say, pick STL. I can then download the specification of that in STL and then send it to a 3D printer and print the thing. Works nicely. Well, other kinds of things we can do here. We're starting to be able to deal not just with spoken input, but also with things like image input. That's a new capability of Wolfram Alpha. So you can say, take an image here, and instead of let's say some image like this, and now we can go ahead and analyze that image. And if you do this from a Wolfram Alpha app on a phone, you can just take a picture and have it start to do image analysis on that picture. You can start to ask it questions about the image and so on. Another thing that we've been doing is to let one upload data. So for example, if you have a device that's taking data on almost anything, you can upload that to Wolfram Alpha. You can upload the data, and Wolfram Alpha's mission then is to try and tell you something interesting on the basis of the data that was uploaded. And that's another new thing. Another thing that we've been doing recently is to try and deal with personal analytics data. Let's see if I can at least bring up something here. Yes. So I myself have been a bit of a data nerd for a long time. That's, for example, a plot of every piece of email that I've sent for the last 23 years and what time of day it went out at. And you can know a lot about yourself by, I have all this data on my daily rhythm and so on. Most people have not been quite as obsessive about keeping data like this as I have. So we have a thing we just released a couple of weeks ago, which is to be able to do this from Facebook data. So you can connect Wolfram Alpha to Facebook, and now, for example, that's a plot of friends, locations of friends, or you can go down, you get this whole sort of book of information about yourself. So actually, if you look, different people have very different kinds of structures of social networks, and each one kind of tells a story, and we're sort of trying to understand what the relationship is between people that you meet and what the kind of graph theoretic structure of their social network is. Well, so underneath all of this, how does this all work inside? It's all based on Mathematica. Actually, Wolfram Alpha is about 15 million lines of Mathematica code now, and you can sort of create any of these kinds of things, in a sense, yourself with Mathematica. One of the things that's sort of a direction is to connect Mathematica and Wolfram Alpha to sort of lots of other things out there in the world. So one type of thing that one can think about connecting to is all sorts of things that one makes. And I suppose I could, rather than, let me not demo Mathematica here, but let me instead get Christopher here to maybe show you some things that he's been making with Mathematica and other objects. So, over to him.
Okay, there we go. Okay, so the first thing I'm going to show connected to Mathematica is a Arduino. And so here's basically the Mathematica code for it. So it's pretty simple. I can connect to it, run these lines. And the general way Mathematica is structured is, you have a function, like plus, and then you have the whatever you input into the function, so 2, 2 separated by commas, that will add them, just so you know what I'm doing here. So okay, so for example, I have a potentiometer inside the breadboard here. I'm just going to try and get the data from it, so I'm going to write Arduino analog read, brackets 0, because it's an A0, and that's the number coming from the potentiometer. So if I move it and then run again, it'll give me another number. So now let's try making it dynamic. So it'll actually update quickly. Update interval, how about 0? Okay, so we'll try and update as fast as possible. So let me actually, just so you can see it, let me pull up a camera here. Okay, so now you should be able to see the Arduino board. And let me just move this to the side so you can see both the number and the potentiometer. So I have this potentiometer here, and I start twisting it. You can see the number. Can you see the number? Should be able to see it. You can see it changing. And now, let me just try and make this look nicer. So I'm going to have a angular gauge and give it a range, 0 to, I happen to know this goes to 1023. So now as I rotate this, you can see this little gauge changing. It's nice for like if you had a sensor that just returned like a voltage, you could visualize what's coming out of it. So I have an example of that here. Now first let me just try something else you could visualize with Mathematica. So I'm going to actually restructure this a little bit. I'm going to call this raw data is this. Oops. And then I'm going to say that this takes in raw data. I'm actually going to make this a row. So I'm going to have another thing being displayed. And now what I'm going to do is I'm going to have the first argument in this row is going to be list line plot of data, which is going to equal here. It's going to equal append to. So it's going to be reading in the data from the potentiometer. It's going to be saving it in this variable data. And so I can say raw data, and then at the beginning I want to initially say that data equals a list of something. And then now it should, oh, that's the wrong size. Let me make it so you can see it. Okay. And now you can see it. So now I've got it plotting, as I change the potentiometer, and it's also got this angular gauge here, and so that's kind of neat. And that would be useful for if you were prototyping something and you wanted to read in your sensor data and analyze it in a neat way and see what you can do with the data. You could use this. So now I'm going to go to another sensor. So I just have to plug it in here. There we go. Okay, now it should be all hooked up. Now this is actually an ultrasound sensor, so let me just face it into the distance so it won't so that it won't just immediately freak out. So okay, this is just a gauge, and the sound is changing depending on, I have to plug this in so that you can hear it correctly. Alright. So now it's changing the sound depending on where it sees an object, and that's the gauge is in inches also. And so you can see it just kind of neat. You can have different sensors plugged into it, and it can also control servos and output and such. But I don't have that in the demo currently. So the next thing I'm going to be showing is another thing controlled by Mathematica, which is what you saw a minute ago in the last demo, the AR drone. So let me just turn this on. And I'm actually going to switch to this computer. because this computer has the right software. Good. Okay. So now I just need to connect. And this is actually trying to connect to. Okay. And I need to connect to the drone when it starts up. Okay, well, it connected. So while it's doing its thing, now I've got, okay, I just need to run the initialization. And, whoops, there's a minor bug in this code I just noticed. I'm just going to quickly fix it, because otherwise it will crash, which would not be good. Okay, there we go. I forgot to put something in the initialization. So, okay. I'm going to try making it fly in a path. So let's first just see the path to make sure that works. Okay, we're just going to try and make it fly in a square. So let's see. First, actually, we can also retrieve the video data from it. So I might as well do that. So you can see that as it's... That's not right. Okay, well, we'll try that again in a minute. Let's try and get it to fly in this path. So I'm just going to actually move it a little to the side so that it doesn't crash into this table over here. So now let's see. So it's going to show, this is the, did it not connect correctly? Okay, well, we have a problem. I'm just going to quickly reconnect. Okay. I'm going to restart it just to make sure it'll work. This code. Okay, now, am I connected to it? Yes, now it should work. Let's try this once more. This is a bug. Okay, let's see if we can quickly debug this. So, oh, I know what the problem was. I know what the problem is. So, okay, I need to redo this. Apparently another thing was forgotten in the initialization. Initialization was not well done. Let's see, I need to run drone connect. Obvious problem. And now it should work. Actually, now the video should also work, so let me pull that up. Good, okay. There's the video. So now, I'm going to have it flying, with the video running, and I'm actually just going to get up to make sure that it doesn't crash into anything. So it's going to go up, it's going to come toward me, go down, hopefully not hit the table, go back, and land. Now, that wasn't quite the correct thing. So now we can try getting it to follow some other path, which, okay, let's see. How about, let's try this in, I hate the middle mouse button on this computer for some reason pastes. So I just tried to use it to scroll, and it pasted stuff everywhere. So now let's see. Let's try a new path. So how about, it's going to go from 0, 0 to, how about 1, 1. So I'm going to make it go, actually -1 because I don't want it to go into the wall. And then, how about, it's going to go back down to its default height, which is 1 meter. Then it's going to, how about move across to the left of 2, and then it's going to go back up to 1, and then it's going to reset. So let's see what that looks like. Okay, it's this path. That's the hopeful path. So it's just some random path. Let's see what happens. Hopefully it does not run into the table or something like that. Give it a little extra space. And now, let's see. Oh, yes. Thank you. I was running the wrong code. I was running graphics. Okay, so I'm just going to paste this into here. And now it should follow this path, hopefully. And not, yes, so it goes up. Now, I don't want it to hit the table. And now it's going to land. Right, so there's a minor flaw of the path. So, unfortunately, I'm running out of time here. So, are there any questions or anything like that? You? What was that? How do I know where it is? Well, actually, right now, there is navigation data for where it thinks it is. Unfortunately, it's not terribly accurate. So in this case, we're just commanding it, pitch, roll, yaw. We're not actually getting feedback from it. And so, yeah, it's an open loop. Yeah. It's something that was written. It's going to be the AR drone happens to be a packlet. The Arduino is a plugin, and hopefully both of them will be available for download soon after a little bit of debugging. Yeah. Right, and you can actually do this. So what we were going to do, except the video ended up being slightly too slow in the current version, which will hopefully be updated, is do image processing. So for example, of this, for this image, I can do, edge detect. Why not? Around this image here, and, there, we have edge detection. And so, I could have it flying doing this, and I could have it doing image processing and returning some variable that could control where it flies. So I could have it, detecting, I could have it flying toward a wall, and if it sees, that this, using perspective or something like that, that there's a wall right in front of it, it could stop before crashing into it at full speed. But that has not yet been written. So I don't think we quite have time to do that right now. So, but yeah, so you could do image processing on it and give feedback. Yeah. I'm not really sure.
I have 4 children. This is child number 3. The 2 older ones are not interested in anything like this. So it's more nature than nurture.
What age did you start learning Mathematica? I think
we're trying to do some things to make Mathematica even easier to sort of get started with than it has been. The thing that's great about Mathematica is you type a very small amount of stuff in and lots of things happen. And that's very satisfying to people who are starting to do programming. And also you can kind of, each piece of code means something because it's a symbolic language. And so you can take what you're doing apart and see what all pieces are. I mean, this chap started learning Mathematica roughly age 6 or 7 or something. But I think it's perfectly doable in late elementary school and so on. And I think we're going to be trying to do some things to make it easier for people to sort of get started using Mathematica. Right now, one of the neat things in Mathematica is you can put an equal sign at the beginning of the line and type a natural language piece of input, and it will go to Wolfram Alpha to get interpreted, and then come back with sort of the precise Mathematica code that Wolfram Alpha came up with for its interpretation of that piece of English. Oh yeah, how about that? Let's see whether that works.
Oh, I'm not. I'm connected to the drone, which does not have. And I don't think there are any.
So.
Yeah, you need internet connection. I've never really thought of teaching mathematics at the Khan Academy. I have seen the Khan Academy, but I have not specifically used it for learning programming.
Yes, but it's a good idea. Yes.
I think we're collectively stunned. Congratulations, Chris, on an amazing demo. I think the most amazing demo.